Today we'll talk about reliability in Wrike's data pipeline. Wrike is collaborative work management platform. It is SaaS. We've got 20,000 clients across the world. Some of them are L'Oreal, Google, Airbnb, Jaguar, and you can see other logos here. We've got different view on work management, for example, workload or image or documents proofing, advanced analytics, Gantt charts, several integrations, and so on. And from data engineering and analytics standpoint, this is very curious because SaaS means that we create, support, sell our product, and attract leads. And we, together with analysts, help these teams speak the language of data and help these teams speak the same language of data. So there is a big space for data democratization there. Our data engineering team is 16 data engineers, actually in 4 teams. We are supporting 250 plus decks on production. We've got up to 1,200 tasks with median of 13 tasks. We've got around 10 updates of production or acceptance each day. We have helped 5 other teams to start using Airflow, and 10 to 15% of our colleagues are using data engineering infrastructure and data engineering sources every month directly, and a lot more than 50% are using it through analytical reports or different integrations. But our journey to reliability started with first analyst using data warehouse based on Google BigQuery. We have provided data by a single instance of Airflow. That meant for us that we've got a lot of bugs found on production. We've got a lot of changes during review process, review with stakeholders based on production data that is available only there, and review with teammates. A lot of delays and partially available data also on this environment. And there was a big difference with the big difficulties with lack of the full picture during code review. And so there could be some architecture problems like not visible, the full picture was not visible for everyone. And on this step, we wanted to start democratization process. It meant for us that we need reliable production and clear guarantees. By clear guarantees, I mean no changes on production, at least unexpected ones. So it means no changes in data structure, no bugs in production, and no changes after review. And no changes in data freshness, so all data should be available all the time and should be available by the desired time. And yeah, we knew that it's hard to do using the single environment, and we have read a beautiful article by Wholesale Banking Advanced Analytics about testing data Airflow. Here is the link to that article. And in this article, they had the distinction between several environments. Most important for us is distinction between acceptance and production. And acceptance is basically the carbon copy of production, where all the data is duplicated and all the data from production is available. And they are using this acceptance environment to make review, to make sure that they can push their decks and their data to production, and everything will be reliable enough. And we thought that this acceptance environment can help in our case too, in order to make production more reliable. So acceptance environment for us is an environment where changes are welcome, to make sure that we aren't going to need them on production. That's our vision. And no changes on production, at least unexpected ones, once again, meant for us no changes in data structure, no changes in data freshness. And because of having these two environments, we shouldn't introduce new changes during release process from acceptance to production. This was our plan of thinking about all of that, and this is the agenda for this presentation. We will have these three sections. And let's start with data structure. If we will return to this table, acceptance in case of wholesale banking advanced analytics is carbon copy of production. It means that they have duplicated all services on acceptance and all data from production to acceptance. This was not feasible for us because we've got a lot of different services. We've got a lot of hardware restrictions, and the cost of making this solution is too big, it's too expensive. And we started to think, can we possibly do it easier? Can we have less infrastructure and less duplication in this case? And luckily, we are using BigQuery, and we have found a solution to make this. We have decided to make acceptance in production in different projects. Sorry for formatting. And it means that they will have isolated quotas and limits. It basically means that resources between production and acceptance will be isolated, and acceptance couldn't affect production, and production couldn't affect acceptance. So that's it on this side. And most importantly, BigQuery allows to make cross-project queries. It means that you can get data from production and save the results of query in acceptance. You can make queries to production and acceptance at the same time if you have the same data location. So for us, it meant that we can store only change data on acceptance without any duplication, so only increment we are working on. And we may take source data from production. So that's it. Let's go to an example. How can it work? For example, we've got a table on production that is called, for example, events client. We make aggregation based on this table, and we have developed a deck that processes it and saves result to acceptance. So our pipeline during a review will look like this. When this data is published, it will be available for stakeholders, the data that is fully calculated on production data, and to our teammates. We can make whole review. We can make sure that no changes is going to be needed on production, and then release the data to production. We can copy data from acceptance to production, or maybe even recalculate it. We are typically copying this data because it's faster and because it's more reliable. So that's it. On this step, you may want to have these two environments and these two DAGs at the same time in order to make zero downtime migration from acceptance to production. But and you can reserve this acceptance for a while, and then you can delete the data on acceptance, and your final pipeline will look like this. You get data, you query data on production and save data to production. That's it, and that will be your pipeline for a long time, and until you decide to deprecate or create the new version. Let's consider an example with new version. For example, we have made the second version of aggregations client. We can make cross-project query to make the comparison between these two tables and show analytics, the statistics of changes. After that, they can migrate to this new table on acceptance. And after all the migration have done and after all validation have passed, we may apply these changes to production, make atomic release, and now your pipeline will be updated. That's how it's gonna look on BigQuery side. Speaking about other databases, you may implement something like this too. You should look for interface separation, resource isolation together, and think about cost trade-offs. You can an expensive solution of duplicating your whole infrastructure, and you may make a trade-off and, for example, have less resource isolation or less interface separation. Speaking about approaches for interface separation, you may think about schemas, base directory names, or naming convention, or even separate databases. Speaking about resource isolation, it can be isolation on service layer, on DB side, like roles, connection pools, quotas, or something like that. On Airflow side, like pools, priority, parallelism limit, and so on. Or on monitoring side, some sophisticated solution like Query Killer or something like that. That's it on database side. I think I have shown you that you can make and implement acceptance without the application of your data. So let's go to the data freshness and no changes in data freshness. We have covered a little of isolation of resources on database side, and I would like to talk more about isolation of resources on Airflow side. We've got a lot of beautiful and big decks like this, like 150 tasks that is constantly changing and constantly recalculating. And working these decks, we could have problems with shared resources, like our web server starts to show errors, our scheduler slows down, or maybe scheduler stops to work, or maybe web server need a reboot in order to show our decks, and so on. So making a lot of changes on during first releases can affect the production environment, the availability and reliability of our production environment. And most of these problems are there only during first time after the release. So if we can migrate and separate resources on acceptance and production, we can scale, we can make our production environment a lot more reliable. So we have decided to use separate airflows in order to do this. But returning to our scheme, we are reusing data on acceptance environment from production environment. There could be DAX that look something like that, DEC events loader that is available only on production, and DEX events aggregators that are available on acceptance and production at the same time. Speaking about DEC dependencies, they will have vice versa dependencies. So events aggregator depends on event loader. And before implementing this events aggregator and events loader typically depend on each other using external task sensor or using external task sensor, but it is not possible in multiple Airflow configuration. So the link between events aggregator on acceptance and events loader on production won't be possible here. And we've got a lot of these links throughout our pipeline, and we thought that we need a good solution here. So we have decided to make a separate service called Partition Registry that allows to communicate between two separate airflows. It is called Partition Registry. This name is inspired by Functional Data Engineering article by Maxim Boshamin. And it means that we are using partition as our level of abstraction. Partition is a unit of work for DEC. Typically, it is hour, day, week, or some other interval in a table or any other data source. And for us, it's a lot more better abstraction to depend on than DEC run or task instance or something like that, because we because we can think about publishing this thing explicitly. We are using operator in order to publish partition status. And we first explicitly publishing our sources. So our DAG structure, our DAG location is encapsulated. No one can depend on any task of our deck. And we can change our decks however we want. We can migrate our tasks and data sources across decks however we want. And more importantly, it means that we can publish our data source only once all validation have passed. And that means that bugs are not propagated throughout our pipeline, and it makes our pipeline and our reporting a lot less available and a lot more reliable. And of course, we have implemented our own sensor here. And unlike external touch sensor, we can automatically identify the strategy for interval. So we are not thinking about schedule interval for our task instance or deck run, and we can automatically process week on hour dependencies, month on day dependencies, custom catch-up, sliding windows, and so on. So that's a lot better. That's a lot easier here. And it turned out that this partition registry is useful abstraction, not only for making the communication across these two airflows, but we have decided to implement more services based on it. For example, we have decided to migrate our monitoring from plugin on web server to this database. And now we have, for example, several severity of delays for our partitions. We've got a base for data lineage, so we can data lineage, sorry. So we can group our decks together and we can make our reporting of errors better. And we have implemented dependencies on pipelines on data that is provided by some other schedulers or some other pipeline engines like Pentaha, data integration, or old Jenkins pipelines that we had before Airflow, and so on. Also, we have decided to scale Airflow using this service too. So we have decided that every one who would like to use Airflow will have their own instance of Airflow with isolated resources, with isolated credentials, and we are going to communicate through partition registry, and that's how we do Airflow data democratization across our company. And we have decided that after some time of using Airflow that we need Kubernetes executor in Airflow, and we need to migrate to clouds, to Google Cloud, actually. And now we have implemented using partition registry and CI/CD easy switch from on-prem to the cloud. And now we have zero downtime migration of our decks from on-prem to the cloud. We've got easy approach for data locality and so on. Speaking about this partition registry, we haven't implemented this, we haven't open sourced this solution yet. Of course, we have implemented it. And you can write me in Slack and I can share the experience with you about this approach of scale Airflow. And we can, if there will be enough interest, we will open source this partition registry database structure and these operators. That's it on no changes in data freshness. And the next section and the last section is no changes during release from acceptance to production. Actually, at the beginning, we thought that it will be the easiest part of all. So when data engineer that is reliable for infrastructure came to me and asked me how should we set up our repositories, I have said, let's have single repository, acceptance branch that is deployed on acceptance environment in DAG folder. production branch that is deployed to production environment, and we will somehow make a merge request from acceptance to production, and it will work. Turns out that a couple of months later, acceptance had twice as much commit as on production. These environments were not similar anymore, and we still needed to release data from acceptance to production. Our software engineering experience told us that we need code freeze to test dependent paths. But as I have said at the beginning, we had 10 releases per day on acceptance or production, and we cannot afford code freeze of the whole repository. So we need to freeze as little as possible. But still, we need to make sure that we review and test every change made. What is the problem? The problem looks like this. We've got a lot of dependencies from one deck to another inside our data pipeline. And this is only the part of the problem because we also have dependency from decks on shared code. And if we look at these parts together, everything will be connected to everything. And there is no intuitive way for us to make code freeze in isolated parts here. So in order to make our release doable and reliable, we need to dive a little bit deeper. No changes during release process means that we need good data isolation during release, good code isolation during release, and frequent releases, as I have said. So let's consider these two parts separately. And let's start with data isolation. It's the most curious one. To understand what good data isolation means, let's start with bad data isolation. It is when you recalculate your data and get different results, or data distribution changes, or this data distribution doesn't change when it should, or analytical dashboards start to focus on the wrong things because analysts had the assumption on data nature that is not true anymore. Or maybe you even achieve your results a lot faster than before, but not because you are working better, because of some problem, some bug in the data. So also something else may be wrong, and you may don't know about it. And that's the problem with bad data isolation. So if data changes, it is safe to assume that your review that you have made is no longer valid. And your manual testing that you have made is no longer valid. And data sources may be somehow corrupted. You should assume this, and it is safe to assume this unless you know the opposite for sure. So how can we work with it? Before the release of any data change, we need to find all stakeholders of this source and all change-dependent sources. We need to make sure that everything works correctly and that they have that they are okay with this data change, that they know how to deal with it. And you should test these all things together and make atomic release. Only that way you can make your data isolated and make the release of new data version reliable. And in this case, the analysts or data scientists may decide to rewrite their dashboards or rewrite their ETLs. But speaking about our pipelines that is supported by data engineering, we may need to recalculate our data. And actually, that's interesting to consider this thing because we may have different strategies for recalculation. For example, we may have we may want to recalculate everything and keep everything up to date. That's the most intuitive approach. The second approach is to preserve history for metrics and make all recalculations and all enrichment on this data of the previous version. And you may use pre-staging, separate data set that is not visible to anyone except data engineers, in order to save this history, the old version of data. And you may also want to support and gradually deprecate the old version of metrics. When this could be possible? For example, you may have a key result for a year, for last year and for this year. For the last year, you would like to freeze your data, and you would like to not recalculate anything because you would like to preserve all the history. So you typically want to use pre-staging pattern in this case. For this year, for example, at the middle of the year, someone decides that they need to create new version of metric. You want to support both versions of metrics at the same time. You use old version until the end of the year to make your baselines for key result right. And you are creating new version for the metric in order to make the planning for the next year, for example. So that's our strategies. And how can we implement this? How can we keep track of data isolation? First, we need to be sure that data that we depend on are not updated after release. So we should know when dependencies are updated after release to production. In order to make it, we have used notification from other teams at the beginning. It's the easiest approach to implement, but it is the most error-prone approach. And we wanted to automate it somehow. So we have decided that we need to version all our changes in data. So when we make any release, we are using semantic versioning in order to show is that a major update or minor update. And we are depending not on data on exact project, but on data of exact version. It means that if data is updated and our code is not updated, we stop the calculation. Our data is still reliable, but not available. That's more a preferred approach in this case. And this thing makes it easier to switch between acceptance and production. You don't need to think where your data is located. You just say that I need the data of exact version, and the code automatically identifies what data, partition registry partition registry sensor automatically identifies where the data is. The other approach that is available to you when you are not controlling the data that is produced is to validate data on your site. For example, you may use the framework called Great Expectation to explicitly specify your assumptions on data nature. You can, for example, we are doing it specifying assertions manually, and we have anomaly detection here in order to make sure that data nature is not changed. So in case the data is not controllable by you, you still may want to validate that there is no changes in data nature, in data structure, and so on. And the other thing that makes this thing not needed in case you have good release process is find all dependent sources before release to the production. If you find all dependent sources before release to the production and make sure all of them are tested and all of them are reliable, that will lead you to the best reliability possible. You can do it manually, and we have done it manually before. So we have used BigQuery history, audit log of BigQuery, and we have used search in Git repository in case we used Postgres or Spark or some other database. And the better and more automated approach is data lineage. You may combine data lineage into your release process, and it will help you to make sure that you have tested the last version of all the data you have. And you may have auto tests in case you are thinking that nothing will gonna change. Auto test may say, no, you're wrong. And in many other cases, they will be quite useful and can help you increase your reliability too. So that's it about data isolation. And as I have shown you, there are a lot of approach. How can we do it? Not thinking about code structure, about repository structure, about merge requests. You can do it using some other tools. So if we are thinking about code organization and merge requests, we are thinking mostly about code isolation. And let's look what good code isolation means. And let's start with bad code isolation. For the most cases of code, the bad code isolation means you have a bug and your pipeline is simply not working. This happens when you have 2 or more decks that use the same code. You update this code or a shared library, and other deck fails. And there could be 2 types of failure. Failure in scheduler or web server. It appears immediately, and the feedback loop here is very good, and you can fix it immediately, but it may be bad for your reliability of the service, availability of the service. And you may have bug on worker. It is visible only during execution. For example, at the end of 4-hour-long task at the start of the next month. And this bug has a lot longer feedback loop. But there is a good news here. If you're using libraries, it's a lot better to implement, a lot easier to implement isolation here. You may use Kubernetes executor and specify Docker image explicitly. You may use venv or virtual environment and something like that in order to implement isolation. Unlike scheduler and web server, where isolation is a little bit harder, you can implement it using FAT-zip approach or boilerplate, just copying your code in several times. But it's not so preferable. And how do we avoid this? We know that there is 20% of code used in 80% of cases. So we can move this code to the library, test it, and track backward compatibility very carefully. And that's the best approach here. And there could be another code, shared code, that is changed rarely. And it's okay for us to have this code, but we are trying to make it as private as possible and make sure that we are not reusing it. This thing is the main reason for DEX to be included in the single repository or in the single merge request for us. So returning to our scheme, our dependency pipeline and our repository organization may look like this. We move common operators and shared code for sources in separate library. We merge SAS, X aggregator, and some other shared code together because they are changing quite rarely. And events loader and SAS Y live separately. That's it. That's it about changes during the release process. And let's go to the conclusion. So how do we reason about reliability? Our production now is very predictable. All interface changes reviewed on separate environment, on acceptance environment. We keep track of all data dependencies and communicate the change to all stakeholders throughout the pipeline if anything changes. And now every source on production can be reviewed, supported by several data engineers, have a clear time of readiness, and all errors can be communicated to all stakeholders as fast as possible. And we are using Partition Registry. It's our own service also to isolate resources of acceptance from resources of production. We recalculate all our data on acceptance because recalculation consumes a lot of resources. And for example, we've got some recalculation that we need to spend 11 days waiting. And we are making all of recalculations on acceptance, and we are copying data from acceptance to production. And it makes a lot less workload during release on production. And we are using it to democratize Airflow, to integrate Airflows among each other with separate credentials and resources to other teams, or maybe when we need to test a new version of Airflow, we can make this through this partition registry too. And I hope I have convinced you that acceptance could be made cheaper. Then the whole duplication and acceptance may improve reliability of your pipeline, and hope it will help. Thank you. Let's go to the questions.
Okay. Let's see. Gerardo, do we have? Actually, I don't. In the chat here, I don't see any at the moment. There we go. All right. So how do you deal with BQ costs when doing automated testing and validation?
We don't. We've got very small data sets during validations and during auto tests, and comparing to everything else, validations are not as cost not as much as calculation or as anything else. So we just think that it's this cheap enough in order to have reliable pipeline. It's okay for us.
Okay.